How many of us here? 25. Okay, let us start our session with a moment of silence or remembrance of our God, our Father. Okay, today we want to continue with our topics uh, with 1 week exercise training to draw the free body diagram, the cut session, and we know how to draw, to write the equation, and we know how to find the equation for V and M. So those are actually the training for the free body diagram actually. So and then we can derive the equation of moment and V from that cut session. Then and from that equation we can plot the graph along the beam. Okay, along the beam we can plot the graph. Today we're going to continue to do that graph by what we call direct method. Okay, direct method. It's very simple actually. This direct method is very simple to find the graph. Yeah, so please look carefully. Yeah, some people call it area under the graph method. This direct method called area under the graph is actually also area of finding the area under the graph. So look carefully, okay? So last week we learned about the point load, and then we continue about distributed load, how to make a graph or equation, how to cut section from a distributed load. Distributed load, there is a constantly distributed or unevenly distributed. And then we have a point moment, that's last week. So we will continue that with that point load first for today. So how do we do that graph by this direct method, by that point load, and then we continue with the distributed load and a point moment later on. Okay, please look carefully. It's very simple. Yeah. So we have this. This is a typical beam, that one. So we have a that one. This is 100 Newton. So 1 meter there, 3 meter there. Simply supported there. So the first step is what? The first step is always find the reaction. Whether you do by this method or the previous method, you will always find the first reaction. So this is the job. We want to draw the shear force and bending moment diagram out of this. Yeah. That's why this topic have to be explained live. It's very difficult to explain by wording. Yeah. So look at this. So we find the reaction there. It's A and B and C here. Okay, RC. So go to first summation force in Y is equal to 0. We know this summation force in Y is equal to 0. What do we have there? RA plus RC minus 100 is equal to 0. So RA plus RC is equal to 100. And then moment. Summation of moment at A is equal to 0. So what do I have there? This title there. A there. What do we have there? 100 times 3 minus RC times 4 is equal to 0. So RC is equal to 300 divided by 4. 300 divided by 4 is 75. And then you solve RE there. RE is equal to 25. Yeah? So those are the simply static that we know. Okay, enough. So the second step, the first step, we finish. Yeah? Now we start with second step. So this is 25, this is 45. Okay, how do we draw the graph when we have this? Very simple. So we draw like that. We have the V there, the 0 there. 0 is there, the positive there, the negative there. And then we have the moment graph underneath that one. Underneath that loading, there's a V and a moment graph there. So this is what we want to do. Okay? We want to plot the moment and the V graph. Okay? So 0 here. 0 here. So what do we do? Watch very carefully here. We start from the left. Left here. We move from the left to the right. But we read everything that we see there and we make a decision. See that? We start from 0 here. When we see here at point A, there's a load up 25. Jump 25. So from 0, jump 25. So from 0 here, jump 25. Yeah? Jump 25. This is 25. So from 0 up 25, you are at 25 now. And then you move to the right here. There's no instruction up or down. So you maintain 25. Up until here, you are at positive 25 now. So the instruction says go down straight 100. So you are at 25 now. You go down. You must go to minus 75. So you go down there. That is minus 25 there. So this is minus 75. And then you go, this is minus 75. Because from here to here must be 100. Go to the right there and then you go down there. Yeah, you go down 100 there. And then from here, there's no instruction there. Maintain that value. Up until here, there's a force 75 up. 75 there, up. So you go to 0. At 0, you finish at 0. And that's how you plot the graph. So from here, after you plot the graph here, so from here, the shear value is 25. From here to here, the shear value is minus 75. That's all. Very easy. Okay? Now look at the second one. The moment there. How do we draw the moment there? There's the moment there. Yeah, moment 0 there. So what do we do here? So there is area under the graph there. There's area here. Area 1 is positive. Why is positive? It's above. Above the graph 0 here. This area under the graph here is negative. So you write down here. What is A1? A1 is 25 times the length here 3. It's equal to 75. That is positive. What is positive right? So area 2 here, what is that? Minus 75 times 1. This is minus 75. So negative right? Minus 75. So how do we plot the graph M? See that? How do you plot the graph M there? Look carefully there. There's a method to plot the graph. You start at 0 there. You are moving from A to B. The area is positive there. The area of load versus time. What is that? V is Newton. And this is distance here is meter. Newton meter. It's actually the moment. The changing in moment. You move from here to here. The changing of moment is that value. You move from here to here, the changing moment is that value. So you move from here to here, the changing moment is that value. So the total changing moment is 75. If you move from 0 and up until here, so the changing moment is constantly moving there. So the value here must be 75. So this is point 1, this is point 2. So point 1 is 0. Point 2, that one, how do you get how do you get 0.2 value? The value of 0.2, how do we get it? 0.2, yeah. Must be the original one, we go from 1 plus the change in area. So what do we have there? 0 plus change in area is 75. So that's why you have a 75. You have a 75 there. So why straight line there? Because the changing is straight line. Because this area, that area, that area, that area, that area. If you go move the same distance, the changing is so constant. So that's why the total area, that one is the changing from here 0 to 75. Why it moving positive? Because the area is positive. Okay, very clear. Now, how about this point 2 here? I go to point 2 or point B there. I want to move, go to point C there. So go to point C at the above area is negative. Now I'm ready at 75. I want to go to point C. I must go to the area going down here. Area is negative. So number 3, you must start at your current position. Current position is 75 plus delta in area. Yeah? 75 there. Your delta in area is negative 75. So the value must be 0. So the changing is also constant. Changing is also constant. The straight line go to 0 there. So that is number 3. There you go to 0. Are you with me, guys? Everybody?
Yes.
Very simple. Very simple concept. See that? So start at 0, you go up. And then you go to the right, there's no instruction to maintain. And then meet 100, go down 100. So must be minus 75. And then you move here, there's no instruction, maintain. And then go up 75, go to 0. Start at 0, you must finish at 0. Same with moment here. You must start at 0, finish at 0. Look at that. How to go from here? The area is positive, you go up. It's not jump at one point because going up is by the distance. It's not jump at 75, it's slowly 75 there. Okay? You move by that distance, only going up by that distance. And then from 75, you go to 0. How is that? Because you move to the right, there is an area negative 75. You move 75 minus 75, you go to 0. Very simple. Are you with me, guys? That's why this method,
Yes.
I have to explain it live. It's very difficult by wording. Yeah? Very simple. Okay, we do some other exercise. So all the work on the right, that one, the area, the point must be shown. Okay? The working, that one must be shown. Okay. Now we have, let's say this one. $100 go down. Yeah? And then at point B there, A there, B, this is 200 or 300 go up. There's 1 meter, 2 meter there, there's 3 meter there. Okay. So, how do we do this? There are 2 ways of doing it. The first, we don't have to find the reaction here. Just do it straightly because from left, we can start from left. What's that? You don't have to find the reaction here. The second one, the second method, we find the reaction. Also can. Yeah, start from the left, there, V. What do we have there? Go down 100. Go down 100. 100. So start from 0. This must be minus 100. Then you move to the right there. There's no instruction up and down. You maintain that until here. Up until here, so go 200. So you must move up to 300. So you must move at positive 200 there. And then maintain that until the end. So what does it mean? This means here, at the wall here, the wall here, you can find this must go back to 0. So there must be a V here, that value 200. Because this must be go back to 0. You can find the reaction by that point.
Tu 200 lah.
So you finish at maintain until here. You don't know just now. Okay? You don't know just now. Then you maintain that 200 there and then stop there. You know that the rule must be go back to 0. So the wall must have some force to force it go down back. That is actually the reason. Okay? And then we go at the moment. So this area 1 is area 2. So area 1 is what? Minus 100 times 2 is equal to 200 Newton meter. So that is negative. Area 2 is what? 200 times 3 is equal to 600. So that is positive. Be careful this. Okay, Newton meter. Okay? So what happened here? You go down. See that the changing in the area is constant. So the line must be a straight line. So the changing is constant. It's not a jump. You must go down slowly. So from here to here, you go down that much. 200. So you go down 200 there. Okay? So this value must have from 0 here. Must go to 0. And then from here, you must go up this much because this is positive. Positive area there. 600. You are at negative. You go straight. You go gradually, but in constant straight line because the area is constant there. Changing is constant. So 200 plus negative 200 plus 600 must go to 400 there. This must be plus. This is how you draw the graph. Moment there. So this point 1, point 2, point 3. So point 1 is 0. Point 2 is 0 plus delta area. 0 minus 200. It's equal to minus 200. So point 3 is what? So minus 200 plus delta area. Okay, what do we have there? Minus 200 plus 600 is equal to 400. 400 there. So, what do we know here? So this must be go back to 0 also. So there must be the wall here must provide. There must be a point moment there. Go back to 0. The point moment is what? Positive or negative? Is negative. Because this is go down, right? Positive up. So go down there. So this is the value here must be 400. So you can find the reaction by this graph. Are you with me, guys?
Yes.
Yes, betul.
This is very. Why straight line here? Because this is constant area. That's constant area. From negative 200 to positive 100. Okay? It's not a jump. Constant. Yeah? If that is not constant, the area is still the same. Let's say the value here is not, this graph is not, let's say like that. The graph is like that. Let's say. But the total here, area here, let's say 600 also. Let's say for example. So still go from 200 to 400, but the graph is not straight line. The graph will be like that. So the initial graph area is high, the second graph is area is small. So the changing at the beginning they have is very high, the changing. The second part is changing is very small.
Yang
That
consider
area.
oh.
Huh? But the value is still 600. If the area is half, that one time that one is half, let's say 600. So the changing is still from 100 to 100. Still to 300 there. Only the graph line straight that way or that way. So we have to learn how to draw that one. You have to think. How can I draw that one? I explain you. The first area here is bigger than the second area. So cannot be like this. Cannot be half of that. Changing is that one. The second half, the changing is high. Different. The first one is high. Second one is low, the area. So must be here. So the first one changing is very high. The second one, the changing is small. High, small. So you decide. So the graph like that.
100.
So when it is straight line like this, so area here and area here is the same. So that's why the graph is same. Half of that, the changing is the same and that high and that high. Those are the reasoning, okay? So you must learn how to develop those reasoning. Okay? Okay. What about this one? Distributed load. Okay? Just move a little bit, okay? Continue this later on. Okay, look at this. I have a distributed load. My omega is 200 Newton per meter. So there's a 4 meter there. Yeah? So I have a reaction here. Remember that? Distributed load there. Evenly distributed load. So RST there. Okay? See that? So this is 200 and 800. So there must be evenly half. So 400 there. So this must be, you do the static one, 400. So how you do the graph? Very quick. Yeah, how you do the graph very quick. See that? The V graph there. You go up, you start at A, you go to B there. Okay? Start at A. Mid 400, up 400 there. So 0, you go to positive 400. And then up until here, you move here, it's not constant. So they ask you to go down. The total going down from A to B is 800. 200 times 4 is 800. So you are now positive 400. So you must move to minus 400 here. Why? Because the changing is 800. So I gradually go to that one. So what is this? This is a graph of V. You look at the diagram of area distributed load on the free body diagram there. So this area asks us to go down. Total going down is 800, but it's not at one point go down. At continuously go down. Continuously go down. Up until that point, the total go down is 800. So from positive 400 to minus 800. And then you go up another 800, 400 then. You go to 0. Start at 0, finish at 0. And then find this area. 1, area 2. What is area 1? This 400. And then this one is half of that. 2 here. 2 and then divide by half. Triangle. Yeah, this is 400 also Newton meter. Times 2 divided by 2. Half. Triangle. The area here is triangle. Same with that one. Area 2 is also minus 400 times 2 times half. So minus 400. So you are from moment there, from point 1 to point 2 there, right? You must move up because this is positive. You move up from here to here. How much moves up? This 400. But how you want to draw? Straight line, or curve up, or curve down? Which one do you choose?
Curve up.
Definitely it's not straight line. So it's not straight line. Because the changing is not the same. The changing is still positive, but becoming less. So how you decide that one? You find the area first. The area is 400. So area is 400, go up. That is positive 400. No problem. The only line. So look at the divide by 2 then. Half that one, half that one. So the first area is bigger than second area. So the changing in the first one is bigger. Put a half there. So this is the changing. So this is the changing. So the first changing is higher than the second changing. So must be this graph. Not this graph. Are you with me, guys?
Yes.
And then, so the total 400 there, and go down by 400 also. So this thing.
Tinggi kau.
So cannot be a straight line because this is not a square. Cannot be this one. Why? Because the first one changing less, second one changing bigger. Use this one, the first one changing more, second one bigger. So this is not correct. This is not correct. So what's left? This one. So go back to 0. So 1,
Oh, kat atas.
2, 3 there. So 1 is 0. 2 is 0 plus delta
Oi.
area.
Dia tak ada.
3 is
Delta
400
400.
minus plus delta area. So 400 minus 400 is equal to 0. That's the working. From left to the right. Start from 0, finish 0. Start from 0, finish at 0. Okay, guys. Okay, we continue this later on. Okay, Assalamualaikum. I give you some exercise. Very small exercise.